Okay, so this is going to get real trippy then.
In our case, in the case of ZK co-processing, there isn't another option.
How do I make my AI agents interoperable?
And those agents will lie. They're going rogue.
Yeah, great question. I'm glad you brought that up. We're huge fans of ZK Sync.
Welcome back to the Rollup, your home for technical talks and open conversations that shape the modular future. Nothing on today's show is to be construed as financial advice. You can see our full disclosures list at therollup.co/ventures. Sit back, relax, and enjoy today's episode after a quick word from some of our awesome partners.
Redstone is DeFi's modular oracle, supporting over 100 clients on over 50 chains and offering 1,000 assets. Redstone is the leader for Bitcoin staking and yield-bearing assets. They offer the most robust, customizable price feeds available in any model. Join the Redstone exhibition today.
What's going on, guys? Welcome back to the Rollup. For today's episode, we have Scott calling in from the sunny state of Florida along with Robbie. We used to have a saying, it's another beautiful day in Florida. Robbie kind of stopped saying that nowadays. I don't know what happened to that saying.
It is. It's another beautiful day in Florida. It was cold there for a while, so it didn't feel like Florida anymore. Scott knows what I'm talking about. It got a little too cold for Florida days, but we're back. We're so back. It's a beautiful day.
Back to perfect 75 and sunny.
Hell yeah. Yeah, Scott, thanks for joining us. I been following Space and Time for a while, primarily because of the interesting name, Space and Time. I feel like it's particularly relevant in today's world. There's a lot of space and time things happening. So we'll talk about that. We'll talk about ZK. We'll talk about AI. Talk about some of the real world stuff that you guys are building out. But before we get into any of that, Scott, what's going on, man? Who's Scott, and why do you care about crypto? Why are you building in this space? And what does ZK mean to you?
Yeah, great to be here. I've been following the Rollup for a long time, so exciting to finally meet you guys on stream and be here. Yeah, so I got into the space after a decade building enterprise data warehouses, like building these petabyte scale databases for Southwest Airlines and Walmart and the big Fortune 500 companies in America. And like, I was during COVID, trading crypto prior to COVID, but during COVID, looking at smart contracts, and was kind of shocked that smart contracts have no access to data. Like coming from a database background, I was like, oh, this is, back in 2020, we all thought like smart contracts were going to completely, debank the bank. And we all thought this was the future of permissionless finance. And I was just shocked that the future of permissionless finance had like no good data tools. So that was kind of the beginning of Space and Time, and exciting to be here. Andy, it's funny you mentioned the Space and Time name. I'll share like a really quick funny story about that. One of our very first VC meetings with like a big name brand VC, when we first started Space and Time in the early days, on the call, I'm very nervous. It's our first big meeting. We have like the senior, very tenured venture capitalist, probably in his 50s, and then the young, like 25-year-old associate. And at the end of the call, it went great. They ended up investing, and the elder gentleman was like, "But you got to change the name. Just I'm not vibing with the name. Like you got to pick a more mature name or something." And was very adamant. And then the young guy was like, "Oh no, the name's sick. The name stays."
That's kind of how I feel. The name's sick, and the name stays. And I mean, I agree on the smart contract front. It feels like we're very much in the elementary school era of smart contracts, where like these ZK code processors that we're building, which I think we should also explain what that is, Scott, and
Yeah.
explain how they work. I also think that name is very bad.
It's a tough
Like,
name.
I think there's a much better way to explain it. Maybe you can explain what a ZK coprocessor is, and maybe if you have a preferred name, because I think coprocessor is kind of hard to understand.
Yeah, I'm actually chat GPTing right now. What's a better name for ZK coprocessor? Because I agree. Like, I think it's a name that scares normies for obvious reasons. All it means is it's a service sitting next to the chain, next to Ethereum, next to a rollup that does some compute, some work, some kind of computational process. It does some work on behalf of smart contracts on that chain, and then proves to the smart contracts that it did that work. That's it. Now, the reason we need to bring some computation off chain and do some work in a ZK coprocessor and prove it back to the chain is because sometimes that work is way too big for what smart contracts can handle. And a great example is processing chain data, or like processing the history of Ethereum. If I want to ask a question from a smart contract as basic as show me the total volume of transactions that Andy's wallet did in December, a question that simple, we got to bring some processing off chain, run a bunch of computations, and then prove it back to the chain, because it's just too much data processing to do in a smart contract. Hence the name coprocessor. It's great.
So what did ChatGPT say?
Yeah, let's see.
Does it have any ideas?
What is a better name for Norm?
And so, like for our audience, we've spoken to a couple of teams who do co-processing, Brevis and Lagrange. We had them on for our Eigenlayer series. If you guys tuned into that and saw some examples, and I think one big example, guys, for those listening, just as more of a primer, is DEX based competitions and like contests and discounts and rebates. And so being able to actually offer certain on-chain addresses and participants rebates, discounts, things like credit card points and airplane miles and these types of things on chain truly are reliant on this idea of a coprocessor. But does our AI friend have any tips, or are they all kind of mid?
They're mid as hell. Proof
Yeah, I figured.
engine, secure math chip. I'm like, bro, these are worse.
Okay.
But that you mentioned the good example of like on-chain loyalty.
Yeah.
I think that's a great example. So like if I wanted to say, hey, all LPs that have deposited at least $100,000 into my protocol, look up how long they've been LPs and reward them an airdrop based on how long they've been an LP. That processing, answering that question of like looking back across chain history and seeing how long they were an LP, that's just a little too complicated for what a smart contract can handle. Thus, we bring it off chain to a ZK coprocessor. We do that processing there, and we prove it back to the smart contract when we hand them the answer. Here's how long, Scott's wallet has staked this token, or how long Scott has been an LP into this protocol.
Cool. And so, a lot of that has to do with kind of like the load that is put on something that is decentralized. And so we've talking a lot about like the nature of Ethereum and of all these blockchains with their validator sets re-executing all of these transactions, and for a very large data set that processes a lot of data, to re-execute that and have it, one node do that and then broadcast that to the other nodes, and then other nodes need to process that. There's just so much redundancy that's a little bit unnecessary. And so with ZK, we can prove it once off chain, bring it on chain, and all those verifiers just verify the correctness of that compute. And so we've talked a lot about kind of like the transition from applications and chains that are doing a lot of this on chain and re-executing all of that to this direction towards ZK based applications. And so, yeah, maybe you could speak a little bit to like the vision for the way you intend applications to use your coprocessor kind of in this new paradigm.
Yeah, the first thing and the most important is that all ZK coprocessors and really all ZK systems in general are designed with like really, really lightweight, fast verification. Put all the onus, all the work on the prover, the ZK coprocessor itself, have it do all the heavy lifting, usually on a GPU, but could be CPU, and then verify super quick, super fast, almost instantly on the verifier side. And that verifier side is intended to be smart contracts. Now, because of that, I see this paradigm shift happening over the next few years, like maybe 5, where less and less computation is done at the smart contract layer. More computations and data processing and like actual like transaction DeFi calculations, if you will. All the calculations, all the work done to build to get you a loan on chain, or get you an airdrop on chain. That'll move off to ZK coprocessors, and really the only thing we'll need blockchains for, like we'll need BFT consensus of us, like you said, Robbie, a set of validators coming to consensus and redundantly executing work. The only thing we'll need them for in a few years is just verifying proofs. Like Ethereum's already become like slowly morphing into this
That
settlement
was
layer for like rollup proofs.
right. That was my next question: is the snarkification of Ethereum and Beam Chain. Like we're already that's a concrete example of Ethereum moving a lot of this computation off chain,
Mhm.
and then some ZK VM that is processing all these transactions and verifying all of these proofs on Ethereum.
Yeah, and the reason is like because the verification step is so light, we don't mind doing it 100 times redundantly or 1,000 times, or across all active validators set right now. But the but
So now, can I ask you one more question? Like, we have this off-chain computation that's being done, right? And then we're going to go and we're generating a proof to the chain, and then the chain one proof, and
one
then
computation done once on one node with one proof, but
yep,
you could verify it quick 100 times.
across the entire validator set. Now I like also had a lot of conversations with ZK proof markets and like proof marketplaces and prover networks is
Yep.
another thing that comes up a lot. How is a ZK coprocessor different, right? Because you do one proof, one computation, generate it once. How is that different from like a prover network or a prover market?
Yeah. So very interesting question. And, to be completely just hot take, I'm a little bearish on proven markets, and I'll explain why. So you've got one server doing the computation once. And in the case of ZK provers, whether it's proving a rollup or proving some data processing, i.e. space and time, Lagrange, etc. Both of those provers, you just need one prover, and you need liveness. You need to keep that prover alive. You need to guarantee that no matter freaking what, it returns this proof up to the parent or to the client that requested, or no matter what happens when Aave asks space and time to give them some wallet information during a lending transaction, we have to return that answer on chain. There has to be this like guarantee that occurs. And so like the way we solve that guarantee is just with proof markets, where we have this sort of like decentralized, almost like a DPIN network of nodes that are raising their hand and saying, hey, I'll run the proof. I'll guarantee it's always on. Me and all my buddies, all these node operators, will all redundantly keep an eye on these client requests, and we'll fulfill them, and we'll guarantee that there's always someone out there in the world ready to go, ready to run this proof. Now, if you had a decent like team that was good at running infrastructure, they could also just spin up like 30 nodes. And yes, it's all run by the same team. And so you could argue that it's centralized, but each node is cryptographically proving all of its work. It's proving what it does. So it doesn't really matter who runs the infrastructure, whether it's a third-party decentralized prover cloud, like you said, Robbie, or the team that's actually like deploying these provers. Long answer, just to simply say, like, all we need is high availability. We need liveness. How we get there doesn't really matter, because all the nodes are proving what they're doing. Whether you run the node, I run the node, doesn't really matter. So I'm like, do we need these whole do we need this whole decentralized DPIN networks that are like onboarding commodity hardware to offer like decentralized proving? I'm a little bearish.
Interesting. Okay, so a couple things. First, a general theme on our show here is that we tend to believe in the trade-off space of making applications faster, more performant, better UX, and just at least a broad step in the direction of just increased throughput is typically worth it in terms of offloading a little bit of censorship resistance, or adding a little bit more of a validator set, or offloading a tiny bit of decentralization, or forgiving a little bit of synchronous composability. Like we're kind of the mind that, like, for example, Ethereum L1 is not going to be verifying all the proofs in the future. I mean, this beam chain idea, like Rob said, or some of these other ones, it may happen in through some sort of snarkification. You may get to this point where there's at least some verification happening, but there is verification layers that will typically like be used, and same kind of thing with ZK code processors, where it's like, again, there is a little bit of trust involved, and you just explained this guarantee process as to where this trust comes in and how you guys effectively maintain that trust through your work with with the proof generators. However, I think that one theme on our show and like that we can continue to kind of harp on is that like these trade-offs are usually worth it. And as long as you're intellectually honest about them and you don't try to act like they aren't, there isn't a trade-off, then it's typically a net positive for the space. So maybe you could, in light of what you just said, understanding the guarantee, maybe that is the trade-off, or maybe like if not, what is the trade-off of using space and time versus the more secure option here?
Well, that's the important thing to explain is like there is no other secure there in our case, in the case of ZK co-processing, there isn't another option. It's bringing a new capability to the space that we didn't have prior. You started this question, Andy, by saying like, hey, we think about the developer experience and the user experience in crypto. What we're not doing is we're not improving the user experience for something that already exists. We're not making it better. We're bringing a new capability in that didn't exist. Prior to ZK coprocessors, if I wanted to ask a question as basic as show me the total volume of transactions in Scott's wallet, a question that simple couldn't be answered natively on chain. Like you can't answer that in a smart contract. So what people were doing was like bringing data off chain into centralized databases, using a centralized oracle to then query that data from their smart contract out of a centralized database, or like using like the Dune API or using the graph, which is not verified. It's not ZK proven. They're not cryptographically proving their query results or proving that the data is not
Yeah.
So all we're doing, we're allowing smart contracts to ask questions of on-chain data with cryptographic proofs, which was a new capability.
Yeah. Just to break that down for the listeners, you could argue like, well, what's wrong with that? Why is it a problem to use Dune or use the graph or use Chainlink to service some of this? Well, Chainlink and some of these companies may be too big to fail, and they might not, take the reputation risk of doing something, wonky. But someone else that's going to go and broadcast data back to the chain or serve up this computation, they bring it off chain into a centralized thing. They can do whatever they want over there, right? So if we're relying on this for like a liquidation price, and I cook the numbers over here a little bit, and then I put that back to the chain, and now the chain is using that for my liquidation price. All of a sudden, I may have profited because I run a liquidation bot, but you didn't actually need to get liquidated. I did it for my own self-interest. And so now with ZK coprocessors, well, we have a ZK proof that verifies, no, this computation was done correctly and completely, and there was no funny business going on off chain.
So you're telling me that space and time is the solution to Arthur Hayes nuking his own users?
Yeah, totally. That's exactly what I'm saying. But yeah, Robbie, I think you got it right. Like, bring these computations off chain when they're just either can't be done at all. Like, there's literally no way to do them on chain, or they're just too massive to be done redundantly 100 times, right? Like,
Yeah.
Like, if I'm gonna sort through like a lending example, let's say Aave wants to give people a better borrow rate if they've already paid off loans. Then we got to go through the chain and we got to find all the times you've paid off a loan quickly and prove it back to Aave that you've already paid off a certain amount of loans while you take out your loan, like during that transaction. And you don't want to wait very long. You're certainly not going to wait 10 minutes. And a lot of these proof systems are very slow. So we're focused on two things. Like, one, make it crazy fast, like return back query results, data back to the client that asked for it, like next block, as fast as possible, sub-second if ideally. And then the second thing we're focused on is just like ensuring that high availability, ensuring that when Aave asks for the total volume of loans that Robbie's wallet has paid off, we get that, we actually return that answer, right? Like 100% guarantee.
Now, Andy asked about trade-offs, which I think is a good question because, the idea of ZK coprocessors in general is a 0 to 1. It's unlocking new use cases that, were not possible before. However, there are, trade-offs in design. There is a design space for how the ZK coprocessor is built. We have Lagrange. We're homies with Ishmael over there, and he's using EigenLayer to leverage crypto economic security to ensure liveness. Basically, make sure that these operators are always online, and that is the proof availability, so that Lagrange is always spinning up these proofs and giving it back to the people that request them. Space and Time chose the Elastic chain, and you guys have mainnet coming up very, very soon. And so I'm curious, why did you guys choose the Elastic chain to ensure liveness and guarantee proof availability for your users?
Yeah, great question. I'm glad you brought that up. We're huge fans of ZK Sync, and really the whole ZK endgame, the ZK roadmap in general is exciting. And I think they've done a really good job of putting together not just a very performant rollup, but a good ecosystem of like tools for developers to connect a bunch of rollups together. Like they're doing a good job of connecting their whole rollup ecosystem across the Elastic chain, which we really like. And our business is delivering ZK proven SQL query results, basically delivering ZK proven indexed data to smart contracts across these different L2s. And so like having like the whole Elastic chain ecosystem of all these different L2s that we can deliver data to is exciting. Now, the reason we deployed our own rollup is because Space and Time is this network of nodes that are essentially like database nodes that collect the data and secure it and come to consensus on it and then like load it into our provers. And so you could almost think of Space and Time as a permissionless L1 app chain specific to running the data. Like you could think of it almost like Arweave or Filecoin in the sense that it's a very data specific, application specific blockchain. It's not a smart contract layer. There's no smart contract execution on Space and Time. All it does is runs queries, gives you data back. That's what our chain does. So all of our staking, all of our liveness and availability, all of our prover slashing and staking and slashing, all of the smart contracts that like onboard node operators and slash them when they do something wrong, or like slash them when they don't deliver a proof on time, that all needs to live in the EVM. So we chose ZK Sync to be kind of hosting all those smart contracts for staking, for payments, for node operator rewards, for slashing, etc. Almost building like our own little, almost like a mini eigenlayer on ZK Sync.
That sounds very modular. So another theme of this show, it tends to be, as you would know, is being big believers in purpose-built chains. Very much, with the exception of several high-quality, extremely high TPS performant general purpose chains, which I have to put that disclaimer in, or else I get yelled at by teams that we've invested in. But my thesis has changed over time. We're generally way more excited about teams that have a specific focus and that have a customized build to adapt and adhere to that specific focus. It's very clear to us that, let's say you have, if it's like you go to the buffet and you have a set menu of what you have to eat that day at a dinner, or you can pick and choose. It's very clear to us that the buffet style with an idea in mind will lead to a better meal than just being like, here's your a la carte menu, build a chain with it. And so, I think that's generally something that we believe in. So I'd be curious to understand that a bit deeper on the technical side. When you say that there's no smart contracts in execution, what comes to mind is like something like a Celestia and a Veil, like just like a data availability layer, or like you said, something like a Filecoin, right? So what exactly is the level of execution? And then uh, why is what is the design aiming to produce, like the outcome? Like what is technical design aiming to produce the best result for? And we can just start there. I'd like to get a bit deeper into the tech of the actual chain.
Yeah, I love that you said purpose built or purpose specific chains, because that's exactly what Space and Time is. So a BFT consensus blockchain that only does two things: collects data from other chains and serves ZK proven queries against that data, meaning serves that data to clients that need it. That's it. Like you can send Space and Time a SQL statement and it'll send you back data, and you pay for that in gas, just like you'd pay for transactions on Ethereum in gas. The gas you pay for is not to write a transaction to the ledger that is Space and Time, but rather to query Space and Time and get back data. Same with Chainlink, by the way. Like we were kind of incubated by Chainlink. We were one of the first projects in Chainlink build, and like very inspired by the Chainlink design of this network of servers off chain that are listening for client requests on chain and returning back data on chain and getting paid per job for that data, essentially in Chainlink gas.
It's no surprise you got the Sergey beard.
And now I need like a light blue flannel. But yeah, so short answer is like purpose-specific blockchain for delivering data, ZK proven as fast as possible, sub-second on massive tables of index data, so you can get back your query result next block. And you're smart. Now you as a smart contract developer can finally ask complicated questions about on-chain activity, about your own users, your own wallets, the people using your DeFi protocol. You can ask questions about them and get back answers next block. But because we're so purpose specific, we don't have smart contracts. We still need to deploy all of our smart contracts for staking and payments and slashing and staking on the EVM, on the Elastic chain.
So is that on ZK Sync's L2, ZK Sync Era, or like where is that being built?
Yeah, so we're doing a lot of work on our own rollup, and then we're putting staking specifically on Era because we're sketched out about like putting hundreds of $1 million of staked SXT on like a brand new rollup that we're not like ready to scale.
That it's not optimized for that. It's not meant for that.
Yeah.
So it's very much like is a good mental model to think of this as like space and time chain is very much a B2B chain. It's very much meant for interactions with other blockchains, not necessarily human users.
Yes. Wow. That's a great way to put it. Space and time chain B2B. Yeah.
Okay, so this is gonna get real trippy then. How have you thought about AI agents interacting with space and time chain? Like, is it like we can kind of open up that Pandora's box unless Rob has any other questions about the technical design?
No, I hear Scott's doing some cool things with AI, so I'm very curious about this.
Wait.
As well.
Also, Scott, are you guys using? I should have done a bit more detail. Are you guys using ETH blobs for your DA? Because you mentioned it's an L1, but it's also Elastic Chain, so you're not.
To Avail. Shouts out Avail. We're
Okay, cool.
all of our DA there. Yeah.
Got it. Awesome. So it's not an L1. You're an L2.
So like space and time chain is just a purpose specific blockchain. So
Got it. Okay. We didn't.
Let's not get sidetracked here.
No, I'll answer the question. It's a good question. I'll answer it. Space and time is a purpose specific chain that serves queries. In addition, we need an L2 to deploy all of our smart contracts for staking and node operations. That's on ZKC.
But the main chain, the main operation chain is this purpose built chain, specifically like this B2B chain. Understood. Correct. Yeah, L1s and L2s is also a thing of the past, by the way. We're leaving that in 2024.
Yeah, I think the definitions will start blurring, especially with sovereign versus non-sovereign, or like rollups that have their own BFT consensus. That's
exactly. Yeah. Like Celestia and Avail can literally build their own rollups without needing to settle to Ethereum. So like, then what is that? So it's all over the place. Okay, cool. So so we have this B2B AI chain, or we have this B2B ZK coprocessor, very effective. It's also an AI chain somehow. Like, how has your mental model of the space broadly changed in the last 3 months with the introduction of AI agents and AI in general, whether applicable to space and time or just in general as a developer?
Yeah, I wouldn't say space and time is an AI chain. Rather, we serve data to AI agents. And like we indexed, 100 terabytes of chain data from Bitcoin, Ethereum, Era, Polygon, Base, Sui, you name it, every major chain. And then like a bunch of off-chain data from TradFi markets as well. So you've got this big database that can either be ZK proven or just like non-ZK proven, just handing data to clients that need it. And so if you're building like a sophisticated AI agent that wants to transact on chain, you need context about what's happening on chain. Maybe like, you need to provide your agent a real-time list of meme coin activity for it to decide on which meme coins to purchase on your behalf. Maybe you need to provide your AI agents information about yields across like 30 different DeFi yield indices to have your agent decide like where to move your money around to find you the best yields. It takes a lot of data, and like we'll be a top quality data provider for the agentic future. And sometimes, rarely, that data will need to be ZK proven when a lot of money is moving hands.
And we are building out an agent. Well, shout out Hyperbolic that is building it out on our behalf. We will have that soon.
I'm good.
Now,
there's been a lot of shout outs today in this podcast. I kind of like this style. Just shout everybody out. We're going to start shouting out space and time after this.
Hell yeah, please do.
Yep. And so we'll have an agent very soon. The name is Roly Poly. For fans of the show, you may have seen this Roly Poly out there on the TL. And so, initially this agent will be used for mostly off-chain things, but eventually potentially on-chain things. And so, like you said, this agent is going to need access to a lot of data and potentially a lot of computational work that has to be done in order for the AI to understand what the state of the chain is, and then to go and then it can go and interact with it. But from let's take away even the crypto, like the financial side of that. Let's just say, we have this AI and, we're training it on the content of all of our podcasts, and it's become very well educated, right? On, the certain database of knowledge, you know, and suppose, there's another AI that's out there that's also very purpose built and it's very specialized on another data set of knowledge. Just say, not crypto or technology perhaps, but what, let's say it's very educated on coffee, right? How can these AI agents start to learn from one another? Maybe those two things should be a little bit more related, but without even getting into like, making transactions on chain, is there a reason that this agent that's very specialized might need to tap on another agent that's more specialized in a particular domain? Space and time can serve a ZK proof that says, hey, here's this bit of knowledge from this other agent. You wanted to consume that. You had to request it from another agent. How do I make my AI agents interoperable? Imagine if the world's GDP moved on chain. Guys, say GM to SafeNet. The newest protocol by Safe isn't a blockchain and it's not a new layer 2. It's a transaction processing network built to send money anywhere and swap anything on thousands of layer 2s from a single universal balance in sub 500 milliseconds. It's fast, it's smooth, and it's simple. And it's built with safe multi-sig level security in mind. SafeNet unlocks smart accounts across multiple chains, allowing users to supercharge security, scalability, and speed. So get started today at net.safe.global and remember to follow @safe on X. Is ZK the right technology for AI agent interoperability?
Interesting, very interesting question. I say no, not at all. Like I would say that ZK is a way to secure data when there's bad actors that are trying to manipulate. Like if an AI agent needs to prove to another AI agent that the data that it's providing it is not tampered, not manipulated, not falsified, sure. So I'll revise my answer. Hell yeah, if agent A is proving to agent B that they're not lying to agent B. Like, here, let me give you an example. Agent A is like, hey, was there a hurricane in Florida today? And it's asking the IoT weather specialist agent that has access to terabytes of IoT sensor data of wind speeds in Florida. That agent says, yes, there was a hurricane today. Wind speeds exceeded 100 miles per hour. Agent A would say, okay, prove it, because I've got $300 million of parametric insurance payouts that I have to pay out on chain. I need to be damn sure that there really was average wind speeds greater than 100 miles per hour. But then you got to ask yourself, is that really an agent use case, or is that just like a data provider proving to a smart contract that manages parametric insurance that it proved? Like, where do agents come into this, right? Maybe there's an agent adjusting the insurance. Maybe there's an automated adjuster. Okay, now
An insurance agent.
Sure, even better. Literally an insurance agent. But the reason I initially said no is because I think about ZK more just like providing data, and I think about agents as needing to transact financially with each other. Phase 1 of crypto agents were chatbots. Phase 2 of crypto agents, crypto and AI, was Twitter bots, like Virtuals and AI16Z and AI-XBT and Eliza, like automating Twitter bots. The next stage will be agents that transact on chain and like manage their own wallet and manage their own private key, and that's going to be all the rage for a couple months, starting soon, of like a million teams building agents that manage their own, that financially transact on chain, which I think is going to be really important, and that will be like the killer use case. And then finally, The fourth and final phase after that will be agents that build their own protocols, agents that build DeFi apps, agents that actually generate working dApps that have a smart contract and a front end and a little bit of a database backend. And that's where we're playing. We've done some co-engineering with Microsoft using like some of Microsoft's code gen capabilities. And like Microsoft's one of our biggest backers, one of M12 is one of our investors. So we do a lot of like AI co-engineering with them in their AI lab. And we've been working on a very mature AI studio for creators to like generate their own dApps that are very data driven. Like since we have all this data, since we have this big database that's ZK proven, let's just help people build like data driven applications, and let's like help users without writing any code generate like a smart contract that's data driven, generate a front end that's data driven, and basically launch their own dApps. I think that'll be like the last phase. And where ZK pays into that is just like securing those apps, like making sure that all the data processing is trustless.
Yeah. Selfishly, for us in our audience, could you tell us a bit more about what's going on with Microsoft's in their AI lab? My uncle works there. He told me that they just invested 80 billion into their AI research. So what's been your experience working with Microsoft personally and with Space and Time, and what's some of the things that you guys have been working on?
Yeah, it's been awesome. They've been a really good supporter, not just on the business side and like introducing us to like major American banks and like other enterprises that want to use our data, but they've also been helpful on the engineering side. So first, starting in like early 2023, we co-engineered with their AI lab like a text to SQL, prompt to SQL system to like get really good at generating SQL queries. And this was kind of before everyone had this. Like we were like maybe 6 months ahead, and then like everyone and their mother built like a text to SQL system. So that was a good like first start, a good like first chance for us to work together. And that evolved, that engagement, that relationship evolved into building this AI studio for non-technical creators to actually generate entire apps. We thought, okay, we can generate SQL queries, we can generate little dashboards. Now let's generate entire crypto apps. Like think like like a little Boyco, something like that, like little mini apps that have a smart contract on the back end that handle very like specific on-chain use cases, which are data driven.
Very cool. And when you originally approached Microsoft's investment arm, M12, you mentioned, is that what it is? I'm not sure the exact
Yeah, M12.
relationship there. Were they open to crypto investing, or were they open to the fact that you guys were building this technology for crypto use cases?
Yeah, they came to us. And now I'll say like I think that mindset has probably shifted a little bit. Like I think that they've
Definitely.
gone all in on AI and they're not doing crypto investing anymore. We kind of like were one of their only significant investments in the Web3 space, but they came to us and they were like looking to make an investment in the data and crypto space in 2022. And they were looking for like high quality teams that were enterprise grade data providers in the crypto space. I think that was, early 22 when the mindset was different. And I think like, as you guys know better than anyone, it's a roller coaster of emotion in people's relationship with crypto. And I think it's swinging back positive right now. I think right now everyone's coming back around in a positive way.
Yeah, that's good.
Yeah, and 22, I mean, real builders, come out in those times. And so I good on Microsoft and their timing, because, that's when if you're getting into crypto in 2022, like you got a real reason for doing the work that you're doing. We come across a lot of bull market warriors that are quite a bit opportunistic, and they are here for a few months to take an opportunity and leverage the positive financial conditions that are happening in the market. But when it comes to real pure technology plays, those are built. Those tend to be built by the survivors and the ones who are really keen on building something during those swings.
Yeah.
I want to loop back to the tech conversation, because I do have one more on the ZK side. And you kind of laid out this agentic future and how you see that playing out. And you also described how these agents could leverage ZK proofs for verifiability and essentially prove that an agent is not lying to them for security reasons. Um, I want to compound the security of verifiable AI with some of the benefits of ZK for interoperability, because we see Superchain building out their ZK arm. And essentially, my understanding is that on the super chain, the goal is that they use ZK. You have chain A and chain B. Let's put names. Let's use Base and Ink, right? So you have Base on the super chain. You have Ink on the super chain. If you want to do some interoperability between Base and Ink, Base is going to have a state, and it's going to send a ZK proof of its state to Ink, and Ink can verify, okay, that's the state on Base, and I can interoperate, and I can send a proof back. And I know what the state of Base is because I have a ZK proof that I can verify to the state of Base. And this illustrates the interoperability properties of ZK, but you're not really looking at ZK for its interop capabilities when it comes to agents proving the state of itself back to one another. You're more so looking at the verifiability of it. Maybe these start to go one in the same. How are you maybe you can kind of like fill in some of these gaps and just, round out the picture of how you see AI serving ZK proofs between agents.
Yeah, I think you're on to. I think you articulated it well that there's always a party A that needs to prove to party B that the sensitive and valuable data they're providing to party B wasn't tampered by party A. Like that's always going to be the case, whether that's Base proving something to Arbitrum or that's my weather specialist agent proving to your insurance agent that there was a hurricane. Like that's always going to be the case. And I think that like when we get to more sovereign, more autonomous agents that are actually making their own decisions and managing their own capital and transacting on chain in a sovereign way without like me micromanaging every little detail of what the AI agent does, then that'll probably be more important. Like it'll probably be more important as time goes on that a sovereign agent can prove that the data that it's providing is accurate. The key is it needs consensus among a set of nodes. Like whether it's Base proving to Arbitrum the state of Base or whether it's proving their weather in Florida, you need a source of truth that's consensus driven or that's like, chain driven, I should say. So like you could have 100 IoT weather sensors in Florida that are all redundantly collecting the wind speed, and then a ZK proof that wraps up those 100 wind speed reports into one final aggregated report provided to the client, the insurance agent. My point is, whether it's agents or not, ZK proofs need a foundation of like consensus among a set of parties that initially witnessed the data. That can be a blockchain, that could be a set of hurricane sensors. Point is, in our case, our whole business is providing ZK proven data, and we need a set of nodes that redundantly witness the data initially, like we redundantly collect data from Bitcoin and Ethereum, come to consensus and prep them to be ZK proven. And so even in the case of AI and the agentic future, you'll still need a set of nodes that can come to consensus that they all witnessed the data initially and signed it so that the agent A can prove to agent B that it's not freaking lying.
Yeah.
And those agents will lie. They're going rogue.
They'll lie and they'll hallucinate. Sometimes it's intentional, sometimes it's not. But what you're saying is that we have all of these parties that are attesting to a certain data set, and then we can wrap all those attestations into a ZK proof. And we can prove, the thing that they are attesting to. I mean, the use cases here, like, prediction markets, settling prediction markets, even using like data to kind of prove the outcome of certain things. I think it's so far reaching.
Or like proving on-chain activity, like agent proving that it did a certain set of actions on chain. I proved that I deposited in a Berachain and then bridged to Monad and then proved that I took a loan out on Monad.
That's a lot of chains you're using that aren't live yet, sir.
This is in the agentic future we're talking about. We're talking about the agentic future right now.
Talking about the agentic future. Right. I must have missed that part.
I think that's part of the value of ZK proofs is that, all of these chains are going to have a ZK verifier, like on day one.
So the ZK verifier is just a set of cryptographic curves that your chain needs to support. Today, Ethereum doesn't really support the curves we need. So everyone's like bending around Ethereum. Like they're kind of dumbing down their proofs to work with Ethereum. So supporting ZK proofs verification is just having like the right set of the right set of like features built into your chain that make it easy to verify the cryptography. And some chains have it, some don't. Solana's working on it.
I've got some more shout outs. What we've got Aligned Layer and ZK Verify that are kind of leading this like verification.
Love RJ and team. Shouts out Aligned.
Yeah, they're homies. Modular ZK verification. So in the sense of like, you know, an Ethereum that doesn't quite have the verification capabilities baked into its chain, Scott and Space and Time are going to serve the proofs. We need someone to come in and verify the proofs and then ultimately interact with the chain. Walk us through like, you know, how a modular verification layer leverages Space and Time and Ethereum and ultimately completes this picture.
Also, one thing, Scott, briefly, what's the bear case for these verification layers as well? Because from what I understand, there's different ways that L1s can just kind of move around them as well.
Yeah, you knew I'd have a hot take. You knew I'm ready to go with the bear case for anything. Yeah, I'll start with the bear case, and we'll go to the bull case.
Sorry, Rob.
That's okay. I think L1's baking in the verification is where Scott's going with this, but maybe
Yeah,
he's gonna.
I mean,
throw us for a
you
while.
already know the answer, right? Which is, I can already verify space and time proofs on Ethereum. I'm not saying you can't verify proofs on Ethereum. You 100% can. You just have to. It's just slow and inefficient. You have to dumb down your proof to get it onto Ethereum, and it's expensive and inefficient because Ethereum doesn't have the right curves. If they did, we could be a sports car Ferrari just cruising on Ethereum. But that arbitrage presents an opportunity for a line layer. Shouts out RJ and team. Love y'all. They could offer a cheaper, quicker, don't pay Ethereum gas. Instead, just pay us a few cents. We'll verify you. We'll sign your proof and we'll relay it on chain for you. And so your gas is pretty minimized. Bear case is, for example, Solana realized by talking to builders like Space and Time, they said, hey, what curves do you need? If we want to make Solana crazy freaking fast for ZK verifying, what curves do you need? We answered that question and they're working on that. So like, I think Ethereum will be slow, and I think a line layer has a great opportunity in front of them for supporting the Ethereum ecosystem. But I think L2s will be quicker to adopt the right curves, and I think chains like Solana will too.
And for any of those unlaunched chains that you listed off, that may be listening and thinking
I have
about
no
what
idea.
but what are the right curves? Like if you were to give them a recommendation of which curves to implement, which ones are those?
BLS 12381 is a common one that a lot of teams need, including Space and Time. And BLS 12381 is not something that Ethereum supports. For the nerds listening, they know what I'm talking about. They're probably begging for BLS 12381 right now in some forum somewhere.
Okay. I am not begging for that. However,
on your knees, Andy.
Thanks, Scott. Appreciate that. So coming to a close here, I think what would be helpful for us and for our audience is to understand the practical future of crypto as we know it on chain and interacting with smart contracts, whether via natural language as running an agent that is kind of your agent assistant, like some of this DF AI stuff, or
hey, you pronounced it. We now know how to pronounce it.
Dude,
DEF AI.
I don't even know what's going on. That Danny Sestia guy is in Antarctica. He's shilling DFAI, DFAI, whatever it is. Yeah, who knows what's going on there? A lot of short-termism happening in the AI space these days. Anyhow, right. So like we're moving forward and we have natural language, you'll be able to implement and write what you're, express an intent almost, which is kind of my current mental model of chain abstraction. Intent is very much like I'm going to enter my natural language into a query. It's going to operate. It's going to send a command to an assistant, agentic assistant, right? But the question here is like, with that in mind, whether agentic or human interaction, when Space and Time Mainnet is live and in the years following, like what is the material differences that you expect to see in the space? what are some of the 0 to 1 ideas that you think are yet to be explored because of the lack of infrastructure, specifically around zk coprocessors? And what, like, do you guys have anything up your sleeve for mainnet?
Those like 4 great questions in one. I'll try my best to answer all 4. Stuff up our sleeve for mainnet, yes. We got some real tricks up our sleeve, especially around launching this AI studio that we've been talking about on this podcast. Is like, hey, here's space and time chain. Now your now your DeFi contracts can query space and time and give back CK proven data, and you as a DeFi developer can build more sophisticated data driven protocols. Oh, by the way, here's a AI studio to build those data driven sophisticated protocols. If you don't want to write code, you can just generate that crap. We're excited, and that'll be all around late Q1. The agentic future that I see crypto enabling, or sorry, I should say the exciting future that I see crypto enabling, that like some 0 to 1 is that like crypto enables crowdfunding and permissionless finance use cases that you can't do outside of crypto. And like I see some people on crypto Twitter complaining like, oh, just because like you built a little Twitter bot and launched a token for it, like that's like web 3 is 2 years behind web 2. Like web 2 has already way better agents, way more sophisticated tech. And I'm like, you're missing the whole point. We're not trying to outcompete web 2. We're not trying to play those games. What crypto enables is whole new games with a whole new financialization model with permissionless finance, where the chain becomes like a permissionless Stripe, becomes an internet payment API for websites and web apps and agents online to like transact in a permissionless way, just like they would Stripe or PayPal, but like without any accounts, like any banks. And so that plus the community aspect, the crowdfunding, like the community socialization aspect of Twitter will continue to spawn these new protocols that can only be enabled through crypto. And an example is like all the AI agents on crypto Twitter that like built their own communities autonomously with their own token. That's something that we'll never see in Web 2. That couldn't have been done in Web 2. It just doesn't have the right mechanics. So we'll take Web 2 tech and we'll build these new protocols that are very community oriented and require some kind of permissionless finance. And that's going to continue for the next 5, 6, 7 years. Beyond that, it's quantum, and that's way beyond any of us, and we're all screwed then. So let's just enjoy the next 8 years.
Love it. Yeah, I think it paints a very vivid mental model of how we leverage ZK, AI, and more emerging technologies on chain in the next 3 to 5 years. So, Scott, thank you so much for coming on, man. Really appreciate this conversation. Learned a lot.
Yeah, Scott, thank you. You did a great job of translating right curve topics into left curves. Thanks.
Appreciate you guys having me on. It's been a blast. Great to meet you both. Talk soon, my friends.
Cheers. Thank you.